So hi and hello. Welcome to our channel named Elgo Exploration. My name is Sami and today we will be going to study inversion count. So this is our first application that we are using some techniques that we know to solve this problem. So the prerequisite is that we should know merge sort. Okay, so let's get started. So our first question is that we have given an array A of size n and we have to count the inversion count. Okay, so what is inversion count? This is the condition that I should be less than j and a of I should be greater than j. Okay, if this condition exists, then we found an inversion pair. Let's see by taking one example that we have an array A of 10 elements. So starting with element 50, what will be the inversion pair with element 50? It will be 50 with 25, 50 with 17, 50 with 23, 50 with 10 and 50 with 90. Because here in this case, let's say I is here and JR will be here and here. Okay, in all these cases A of I is greater than A of j. So 50 with 25, 50 with 17, 50 with 23, 50 with 10 and 50 with 90. So this is nothing but an inversion pair and we have to count the number of inversion pair. Okay, so what will be the approach to solve this question? The first approach is that will be brute force, that is checking for every element and counting its pair. That is 50 with 25, 15 with 17, 15 with 23, 15 with 10 and so on. And after that, starting with 25, so 25 with 17, 25 with 23, 25 with 10, 25 with 19 and so on. So if you do this, the time complexity here will be order of n square, right? And space complexity will be order of 1 because we are not taking any extra space. So we have to reduce the time complexity. So what will be the optimized approach? It will be taking the help of merge sort. Okay, so again I am telling this that you have to know the merge sort, otherwise you won't get anything. Now we have an array contains 10 elements. Now observe here, this is nothing but we are merging the array. We have two array, right? Firstly we have to divide it and let's say we have sorted it. So 17 and 25, 50, 88 and 90, and here also 10, 19, 23, 79 and 86. Now our last step is that we have to combine it, right, in the merge sort. How we will combine it? We will take the help of two pointer technique, that is pointer P1 will point at 17 and pointer P2 will point at 10. Now let me first write the condition of inversion count. I should be less than j and A of I should be greater than A of j, right? So 17 and 10. Do you think that this is an inversion pair? Yes, it is, because 17 is greater than 10, right? So this is an inversion pair. So don't you think that since 10 is lesser than 17, then 10 will be lesser than all the elements present in this array, right? So the pair will be 25 with 10, 50 with 10, 88 with 10 and then 90 with 10, right? So here we get 5 inversion count. Now we will simply write 10 here. Okay, and we will increment the pointer p2. Now 17 with 19. So here the condition doesn't match, so we will simply put 17 here and we'll increment the pointer p1. Now 25 with 19. Here the condition satisfies because 25 is greater than 19. Due to this, 19 will be smaller with every element starting from 25 till 19, right? So let's write another pair, 25 with 19, 50 with 19, 88 with 19, and then 90 with 19. So your count will be 4. Now observe here how we are getting this count. It is simple. Let's say here this is left and this is right. So what will be the mid? It will be 4. So to get the count, we will simply do mid minus pointer p1 plus 1, right? So here the mid is 4. Let's calculate this is actually right or not. Mid is 4 minus p1 is pointing at 1, 1 plus 1, that will be 4. Okay, so I hope you got how we are getting the value count. Now we will now write 19 here and we will increment the pointer p2. Now p2 is pointing at 23. Here also condition satisfies, that is 25 is greater than 23. So the pair will be 25 with 23, 50 with 23, 88 with 23, and 90 with 23. So here also the count is 4. Now let's go further. We will write 23 here. Now p2 is pointing at 78. 25 is lesser than 78. So we will write 25 here and increment the pointer p1. Here also 50 is lesser than 78. So we will write 50 here and increment the pointer p1. Now 88 is actually greater than 78. So condition satisfies. So the pair will be 88 with 78 and 90 with 78, right? So here the count will be 2, and then we will write 78 here and increment the pointer p2. Now 86. Here also 88 is actually greater than 86. So we got another pair, 88 with 86 and 90 with 86. So count is 2 and we will write 86 here. Now p2 is actually out of bound, so we will simply put remaining element from p1 till last, 88 and then 90. So how many pair we did? We got 5 plus 4 plus 4 plus 2 plus 2. This will be 9 plus 8. That will be 17. Right? So we got 17 pairs. Now what about the remaining inversion from this array? It will be handled while merging this array. Okay, so what will be the pseudocode? I will be left, j will be mid plus 1 and k will be left. It is similar as merging the two sorted arrays. Okay, so with the help of while loop, I should be less than equals to mid and j should be less than equals to right. If this condition satisfies, then we will perform two operations. If a of I is less than a of j, then we won't do anything. We'll simply put a of I in a new array and we'll increment k and I. If this is not the case, then we will put first a of j in new array, increment the k, increment the j, and we will simply calculate the count. That will be mid minus I plus 1. Okay, so how much time this will take? Since merge sort take order of n log n, this inversion count will also take order of n log n. So due to this, the time complexity is order of n log n. What about the space complexity? It will be order of n. So in this way, we actually do the inversion count. Now, please dry run it by yourself. Due to this, you will get a clarity. And in the next lecture, I'll be putting the code for this problem. Okay, so thank you.